The lie of the sunset. Let's see what that's all about. Works like this. What a sunset is then is that you're here on Earth, and maybe you're right here on the beach or in the desert or something, and you're just watching the sunset. And what the sunset is, of course, is when the sun goes below the horizon. So I think you maybe remember that from a previous video. The sun doesn't actually set or anything like that. It just has to do with the fact that the Earth is rotating and the sun eventually goes below the horizon. That's not the lie of the sunset, but that's actually what it is. It has to do with the sun, sort of losing the sun below the horizon. So let's just talk about that then. So if the sun is like right about here, then what's happening, of course, is light from the sun can go into our eyes. And maybe our horizon at the moment, if you sort of remember many, many lectures ago, is sort of like this big flat line that when things go below the line, we can't see anything below the horizon. So it's greatly exaggerated here because I can't sort of get the big curvature of the Earth in there, but this is sort of our horizon line in here. I hope you remember that from a previous video. So what happens is if we're looking at the sun here like this, it's getting close to our horizon, which means the sunset is about to happen, and we're just enjoying ourselves. And of course, I guess I'll try and do it this way. The sun gets a little bit lower and lower and maybe lower like this, and it starts to get interesting now because it's sort of at the horizon. It gets lower and lower like this. And so it turns out that this configuration right here is sort of where the lie is. Okay, so I hope you got that. I'll just sort of maybe redraw those suns back in here. But it was here, and it sort of keeps going. So it's sort of like this position right here, which is where this lie starts, because here's what the lie is about. It turns out that, let's think now about the law of reflection and refraction as it might apply to the sunset. So it'll work like this. Let me make my horizon line there just a tad bit shorter like that to make this work out. But okay, I hope the horizon is clear to you. So what happens, of course, is if we want to see the sun, as I drew up here, light has to go into our eye. That's the only way we can possibly see the sun. And so light generally goes into our eye from all these configurations here. So we see the sun down there and see the sun down there. And that's where we see the sun where it is, because of the light that goes into our eye. But what happens in a situation like this? Well, the sun is now below our horizon. So maybe I will extend that line just a tad bit more out like this. It is below our horizon. So let's just track a light ray now as it goes into our eye. So here we go. The light ray is going to leave the sun like this. It's going to come up maybe like this or something. It's just going to sort of leave the sun and come up. And sorry I interfered with the horizon again. I don't know how long to draw that, but here's this light ray coming out of the sun. Then you go like, okay, wait a minute. As light leaves the sun, this whole region here is the vastness of outer space. Remember, that's like our solar system, and there's nothing there. Okay, we're being very technical now, but we know some stuff about light. So all in this region right here, this is basically the vacuum of outer space that has an index fraction of like 1, because there's nothing there. Light leaves the sun and it travels through the vacuum of the solar system on the way to our eye. Okay, but then what happens is the light ray starts to approach the Earth and starts to approach us on Earth. What does it encounter? Well, if you said atmosphere, you would be right. It starts to encounter our atmosphere. We have this thick atmosphere. Actually, it's really not that thick, but we have this atmosphere that sort of surrounds us on Earth like this, don't we? So there's that thickness that we live in, okay? So now you got to think about your optics laws. What happens right here? What happens as a light ray that leaves the sun in the vacuum of space, 1.000, travels and hits our thick atmosphere, or our relatively thick atmosphere that's thicker than outer space anyway. So this is thin out here, and remember the atmosphere over here, this is where it's getting thick because of all this air and stuff. So what happens as a light ray goes from thin to thick? Well, I hope two things are entering your mind. I hope the bending is happening, because that's what happens when light goes from something thin to thick. And I hope, because it's thin to thick, I hope the towards enters your mind. And by towards, I mean towards the normal. So we can actually go to this spot right here, this spot where the vastness of outer space reaches the atmosphere right here, and draw normal. My goodness, a normal way up in the sky. Like there's that normal right there. And here's this light ray coming in from the sun. So what it's going to do now, it's going to bend and towards the normal. And I know it's going to bend towards the normal because it's going from the thinness of outer space to the thickness of our atmosphere. So let's just continue that ray bending into our eyes. And there you go. And this trajectory of the light ray right here is essentially the lie that I'm talking about. So I said in a previous video also that your brain doesn't know about bending. So when you get this ray going into your eye, maybe let's draw this in a, well, let's just thicken it up a little bit here, because this is our key ray here. That is sort of about this lie that we're talking about. So let's just thicken it up so we sort of are focused on the one ray. So there's the normal right there, and there's the bending happening. So remember, your brain doesn't know about bending, and so what it thinks is happening, it actually thinks that this ray came from all the way over here. So that's sort of the issue here. The sun is actually down here, but your brain thinks it's right here. So let's get that labeled on here too. Like this is actual. This is the actual position of the sun, but your brain thinks it's here. Like your brain thinks the sun is right there. And that's no fair. But this atmospheric refraction is a real effect that happens, and it affects all kinds of science and observations and things. So that's essentially the lie of the sunset, is that when you see the sunset, which is here when the sun is below the horizon, you're actually seeing it above the horizon. So by the time you see the sunset, guess what? The sun has already set. And that's the lie. The lie of the sunset. When you see a sunset, the sun has already set. And so that's either going to be a happy event or a sad event for you. I don't know what to tell you, but it is true in this case here. Let's just recap one more time here on the lie of the sunset. That here's, extend that horizon line. That I sort of see where everything's going to go there, something like this. Remember, the horizon isn't actually a line. It just sets our view here. That here's the sun below the horizon. It has set. But its light ray that travels through the solar system sort of encounters our Earth's atmosphere right here and bends or refracts into our eye, a thin to thick interaction bending towards the normal into our eye. Our brain doesn't know about bending, thinks the sun is right here. So you're seeing this beautiful sunset. Oh, how nice. Let's take pictures. And it's very romantic and all that stuff. But the sun's already below the horizon. It's already set. So sorry about that. The lie of the sunset is when you see the sunset, the sun has already set. Being really strict with the definition here that already set means the sun is below the horizon. So anyway, sorry about the bad news. Can't do anything about optics.